Good morning. I hope this video finds you well. I wanted to take a moment and first of all, welcome you again to my classroom. As I told you in the previous video, this is the classroom that I actually use for teaching Chinese children English. Haven't done that for quite some time, but I thought about taking it back up this summer, and so I didn't take down all of my decor, and I'm kind of glad I didn't, because now we have something better than just bare walls to get us through this digital learning process. So with that being said, I did want to walk through all three of the examples for topic 7.5, and then two of the examples in this video for topic 7.6. You should be able to see my screen right here with my document camera, and we will be walking through these videos or these examples via video, and hopefully it'll answer any questions that you might have. So looking at topic 7.5, example 2, this is on page 288 in your textbook. We're going to factor this x squared minus 11x plus 18. And as you remember from our previous example before we left school, we could do that one of two ways. So we could factor this either via the box method, or we could factor using the cross method. Now, if we use the box method, we know that this box is x squared, and this one has to be a positive 18. So with this being x squared, to get x squared, we use our area. Area is length times width, so that would be x times x. So now we've filled out one part of our parentheses because we know this is going to wind up being x and x. We just don't know what the other piece of it is, the other term. And so if we use our cross method, the cross method says, what can we multiply together to get a positive 18 and then add together to get the negative 11, which is the coefficient of the second term. So to figure that out, we have to list all the factors of a positive 18. I always start with the easiest one, 1 and 18. Well, if we add those together, we're going to get 19. So I know that doesn't work. So then we have 2 and 9. If we combine 2 and 9, 2 plus 9 is 11. So that looks like that would work. But now we have to think about the signs. The sign on your C part, your third term, is a positive sign. Well, we know that a positive times a positive equals a positive, and a negative times a negative equals a positive. Well, if we want a negative 11x right here, then this 2 and 9 are going to have to be negative, because 9 plus 2 is 11, and to make them a negative, it's going to have to be negative 2 plus negative 9, which would equal a negative 11. So our solution is x minus 2, x minus 9. And we can verify that going back to our box. If we put the x minus 2 here and the x minus 9 here, and continuing on with the area model, x times a negative 2 is going to give us negative 2x. X times a negative 9 is going to give us a negative 9x. And then just verifying, negative 2 times negative 9 equals that negative 18. So that all works out, it checks out, and we're good to go. So your next example is going to be example 7 -5, example 3 on page 289 of your text. And so here they're asking us to factor x squared plus 5x minus 6. So here we go again. We can do the box, and the box is a great way to check our answers as we finish. So we know that this is x squared, and we know that this is a minus 6, and this has to be x, and that has to be x. So once again, we've got our parentheses started, but that's as far as we've gone, because we need to figure out what goes in these two boxes, which is directly derived from what goes up here and what goes up here. Now we're dealing with a -6. So remember that a negative times a positive is equal to a negative. So if we go to our cross method, we're looking for something that we can multiply together to get that -6 and add together to get a +5. So our factors of 6, once again, factors of a -6 this time, you've got 1 and 6. The difference, since we know we're dealing with two different signs, the difference of 1 and 6 is 5. But the question now is, which one is going to be the negative number? Well, since you have a +5, you want your bigger number to be positive. So if we make the smaller number negative, then what is 6 minus 1? Well, 6 minus 1 is a +5. So that works for us. We've got -1 and +6. And so we can go ahead and fill out our parentheses and double check them right here. Using our area model, x times the length of this box, +6, will give us +6x. And then x times a -1 minus 1x. When we combine these two, we do get our +5. And then +6 times a -1 does indeed equal the -6. So an excellent way to check your work is to go back to the box method and use your area formula, length times width, which is what we've been doing all year. All right, so then we have example 4. Example 4 from topic 7.5. I didn't write the page number on this one, so let me see if I can find it real quick for you. Example 4 on 7.5 is on page 289 again. So page 289. And now you can see that this one looks a little different because it has an X and a Y. So we're just simply dealing with two variables this time, but we're going to apply the same principles. So, don't panic or stress about the fact that you have an X and a Y. We're going to break this apart just like we would in the previous examples. So I've already got my box drawn here for you to see what could possibly, and I'm going to zoom out just a little bit so that we can see this a little bit better. Give me just a minute. So we're asking what could possibly be multiplied together to get us the x squared in this corner and the 24y squared in this corner. We can still use our cross method. which says, what can we multiply together to get 24? And it's a positive 24 here. We know it's got to have the y because it's got the y squared here. And so that's why I've already got the y's written on the box. And then what can we add together to get this positive 10xy? So we know that when we multiply x and y together, we're going to get that xy. So let's just focus on the coefficients. We're going to list our factors of 24 once again. This time we've got a positive 10 and we've got a positive 24y. So we know we're looking for two positive numbers that we can add together to get that positive 10xy. So to do that, I always start with that 1 and 24 because it's the easiest factor I can come up with. So once we have 1 and 24, then we can break it down further, 2 and 12, 3 and 8, and 4 and 6. Now once you get to 4 and 6, if you remember from your greatest common factor, you're going to repeat again and you're going to start going the other direction. And so it doesn't do us any good to continue on, because if we start looking for what can we combine to get the positive 10 right here, well, this is 25. This 2 plus 12 is 14. 3 plus 8 is 11. But 4 plus 6 is 10. So we know they're both positive. So we can just go up here to our box, plus 6y, and double check our work. So we have x times 6y. That's simply 6xy. Now some of you in some of your work and even in the Zoom session that we did yesterday, I noticed that you said 6yx. Well, our standard nomenclature is that you list your coefficient and then your variables in alphabetical order. So you might as well just go ahead and start training yourself to do this, because it'll serve you very well in your future math career. So 6xy is the way that we would say x times 6y. Then x times 4y. So that would be 4xy. And we know that 6 times 4 is the 24, and y times y is y squared, because we're simply adding those exponents. Anytime you multiply something with the exact same base, you're adding the exponents. And so we have y to the first power times y to the first power. We just add these two exponents. That gives us y to the second power. And you know that already because you're used to doing this x. So therefore, our solution to this one would be x and x, just like we started with before to get that x squared. Then you have plus 4y plus 6y. And as we were trained, I went ahead and boxed my answer for you. So that completes all of topic 7.5's examples. If you have not already completed the try-its that go along with 7.5, please make sure you log into Google Classroom and do so. Those are counted in your weekly grades for this digital learning process that we're endeavoring on together. I do want to move ahead because this is a normal extension upon factoring. But this is factoring when your a, if you remember, the standard form of a quadratic, it's a squared plus bx plus c. So in these situations, we've got something that looks a little different. We've got an x squared here. We've got an x I'm sorry, an x cubed here. We've got an x squared here, and then over here we just have an x. So one of the things that we have in common is that each term has an x. Well, that doesn't fit. That doesn't fit our quadratic formula, the ax squared plus bx plus c. So that would make it very difficult to factor at this point. So we need to make it a quadratic. And the way we're going to make it a quadratic is we're going to break down each term into exactly what the terms are. So we have 3x cubed. Well, we know that 3x cubed is simply 3 times x times x times x, because with that x being the same base, we're adding those exponents again. Then we're going to break down the 15x cubed. The 15x cubed is simply 3 times 5 times x times x. Now, why did I pick 3 times 5? Because of this 3 right here, and I'm looking to simplify this out to reduce it down, then I'm going to automatically look and see if I can use this 3 to simplify these so that I have something in common. It's all about looking for patterns, and I know a lot of you guys are super great at looking for patterns. We just have to marry that looking for patterns knowledge that you already have in your brain with your multiplication tables, which you tried to dump. So grab those multiplication tables, brush them out of the attic of your brain, and let's look at these patterns and try to find out where we can simplify this so that we can factor it. So I started with the 3 times 5, and then times x times x. And then finally, this negative 18, I know that 3 will go into it, and so 3 times a negative 6 times x. Well, why did I make the 6 the negative and not the 3? Because these 3's are positive, and I'm still looking for that pattern and trying to find what's in common. And so I needed a positive 3 for that to be in common. So then, once I've done this, I can look and see I've got a 3x here. I've got a 3 and an x here, and I've got a 3 and an x here. So I have something in common, and once you find that something in common it has to be the exact same in every single term, you can pull it out. So I'm going to pull that 3x out. Once I pull the 3x out, then I need to see what is left. So that's what I'm going to include in my brackets, is what's left. So in my brackets, I'll have this x times x. Well, that's x squared. Then I have on my second term 5 times x, because I've used the 3 in the first x to pull out in my 3x. So I have, and it's positive, so I have 5x. And then finally, the only thing I have left on that third term is that negative 6. So I'm going to put it inside my parentheses. Now we have a quadratic. It meets the quadratic standard form of ax squared plus bx plus c. So we can factor it using our standard factoring methods. So I'm going to draw the box, and I'm drawing the box because it's very helpful for us to double check everything once we get done with the cross method. Now, if you're really good with your multiplication tables, you may be able to do this box method without even going through the cross method. But the cross method is really good to be able to see what you're trying to do. So you're trying to multiply two numbers together. That'll give you a negative 6, and then add two numbers that will give you that positive 5. If you remember back from a previous example that we've done today, this looks very similar. So we have that x squared plus 5x minus 6. And we found out that -1 and 6 we could add together to get our positive 5. And then we could multiply it together to get our -6. So our answer is going to be x minus 1 times x plus 6. So we're going to say -1 plus 6 minus 1 plus 6. 6 times x is a positive 6x. 6 times a -1 is the -6, so that checks out. And then -1 times x is a -1x. When we combine these two on the diagonal, we get x squared plus 5x minus 6, so that checks out. And then how do we write our solution when we've had to factor this common term out? 3x times x minus 1 times x plus 6. And that would be your solution. So just remember that your first step, when you're dealing with something that is not in standard form of a quadratic, like we did right here, break out each individual term so that you can see what do they have in common. You're looking for patterns. Take those patterns out and then open your parentheses and simplify it into a standard quadratic form that we can then factor. All right, so then we are going to look at the final example for this video, trying to keep it short, sweet, and easy to follow, is we're looking to factor something that does not have a as 1. Everything that we've looked at this far, either we could break it apart as in the last example, or all of the examples in 7.5, your A term was just 1. There was nothing there because it was an understood 1. With that being said, we have to remember, breaking it down, how do we factor, and identifying our terms. And so the very first thing we want to identify is, what is our A? Well, our A is 6. And what is our C? Our C is 4. So when we multiply our A times our C, we get 24. So now we're going to look at factors of that 24 that we can get the positive 11, because that's what we're trying to factor, is this positive 11. And that A times C is a big part of that. So we know we're dealing with positive and positive. So just writing it back down again here, we've got a plus 11x plus 4, and A times C is equal to a positive 24. So we can do our factors like this in the cross method. And we're looking for what can we multiply together to get 24 and add together to get 11. So if we list our factors of 24, we've got 1 and 24, 2 and 12, 3 and 8. And I'm going to stop right there, because this is 25, this is 14. But what is 3 plus 8? The way I like to add, and I don't know if y'all do this, but I start with the 8. I said 8, 9, 10, 11, and I just count the 3 legs of the 3. So 8, 9, 10, 11, that helps me if I don't have it mentally memorized. And so that equals 11. So I know that that's going to work. So then the next step, since we know the pieces are 3 and 8, but we have to deal with that 6, because we have a 6 right there. We can't just do, x and x plus 3 plus 8, because that's not going to give us what we need. So we're going to have to deal with the 6. So then how do we deal with that? It gets a little bit more complicated, but I know that you can do it because we worked through the last problem that said, okay, what can we factor out? What do we have in common? Looking for those patterns. That's going to be very similar to what we're looking for here. So here we have, we're going to rewrite this. We have 6x squared plus 3x, because we have this 3 and 8 here. And you may even be able to see it better by putting it in your box at this point, because you know that you're going to have 6x squared here plus 4 here. And to get that 24, to get the 24, you're going to have 3 and 8. So you got 3x and 8x. And so we're trying to figure out what goes in these two boxes. So we have the 3x and 8x. We know that 3x and 6x have something in common. They're 6 and 3. And then we have plus 8x plus 4, going back to our original equation here. So now that we have the middle component broken out into the factors that we decided would be the proper factors that would give us the 11 once we multiplied that a times the c. Don't forget this part, very important. We can group these factors together like this. When we group those factors together, now once again we can look to see what is the common piece in each of those sets. So if we look at just this set by itself, you can factor out that 3x, because we know that 3 will go into 6. How many times? 2. And x will go into x squared 1 time. So then 3x will go into 3x. Well, if we look at 3x over 3x, that equals 1, because anything over itself is 1. So we can say plus 1 here. Then we want to see what pattern, what things in common can we see right here? Well, when we look at that 8x, we know that 2 times 4 is 8. So we can factor out the 4. Once we factor out the 4, and we can't factor out an x, be very careful because this 4 does not have an x. So we can't factor out an x like we did over here. See, both of these had the x, so we could take an x out. But since both of these don't have an x, we can't take an x out. So here we have 4 times what equals 8x? That's 2x. 4 times what equals 4? Plus 1. Do you see a pattern? 3x times 2x plus 1 plus 4 times 2x plus 1. Now we have two things in common again. We have this piece. And given our rules of multiplication, then we can go ahead and group these two pieces and consolidate these two pieces since we have 2 of them. So our final answer would simply be this 3x plus 4 times 2x plus 1. And so that's our final answer. Now, do we want to check it? Come over to our box. If we have 3x plus 4 and 2x plus 1, 3x. 3x times 2x is 6x squared. 2x times a positive 4 is 8x. 1 times a positive 3x is 3x, and then 1 times a positive 4 is positive 4. So if we bring this out, do we get 6x squared, add the ones on the diagonal, 3x plus 8x, that's 11x, and then plus 4, which is exactly what we started with up here. So we are good to go. Everything worked out perfectly, and I hope that these answers or working through these problems in a slow manner with me has helped you. Please let me know and respond to this video if you have any questions. Thank you so much. Look forward to seeing you again on Zoom.